Computers have evolved a lot, but are they actually capable of evolving further? Well, I'm Priyanshu Khadia, a first year BTech computer science student from Charuset, and today I would like to talk about photonic computing, merging optics with digital logics. So let's start. Photonic computing. Photonic computing represents a paradigm shift in the world of computation, merging the realms of optics and traditional digital logic. By harnessing the power of light, the optics, this technology aims to overcome the inherent limitations of traditional electronic computing, paving the way for faster, more energy efficient processing. It's a breakthrough technology poised to redefine the landscape of next generation computing, promising to revolutionize various fields from artificial intelligence to data processing. Now, let's see what photonic computing actually means. What is a photonic computing? Photonic computing leverages light, the photons instead of electrons used in traditional electronic computing to perform computational tasks. This approach enables faster and more energy efficient processing, circumventing the disadvantages or we can say the limitations associated with the traditional electronic computing. Now, let us talk what problems traditional electronic computing has in present times. So, humans have reached the electronic bottleneck. Bottleneck in context of digital electronics is a condition when a point arises from where no major advancement in a system or we can say a technology can be brought. The term bottleneck refers to both an overloaded network and the state of computing device in which one component is unable to keep pace with the rest of the system, thus slowing overall performance. It also results when there is not enough data handling capacity to accommodate the current volume of network processing traffic. Another disadvantage is that electrons are slow moving compared to what photons does because photons move at the speed of light. Another disadvantage is power consumption of electrons for performing tasks is high. Now, what advantages does photonic computing provide us over traditional electronic computing? Let us discuss that. Photonic computing offers significant advantages over traditional electronic systems, making a new era in computational efficiency and performance. By replacing electrons with photons, this technology overcomes many of the limitations inherent in traditional computing architectures. The advantages are it provides faster speeds. Photons enable quicker signal transmission. Second is energy efficiency. Reduced energy consumption lowers operational costs. Another advantage is reduced heat. And the main advantage, parallel processing. It can perform tasks very well, very efficiently, and very rapidly. Another advantage I would like to talk about is that photons of different wavelengths do not interact with each other even in same space. As you can see in the picture, suppose one photon is of wavelength dedicated to red color and the another one is the blue one. So if they travel in the same medium simultaneously, they do not interact with each other. That's the advantage of the motion of photons. Another advantage is that photons can do wave interference. The first picture depicts constructive interference, in which both the waveforms are in same phase, Digitally, it's logic 1. The second picture depicts destructive interference. Both the waveforms are in opposite phase, which depicts logic 0. Now, let us talk about how photonic computing works. At its core, photonic computing manipulates photons within optical circuits to perform calculations or transfer information. Here's a simplified breakdown of some essential components. Photonic chips. These integrate optical and electronic elements to facilitate operations like logic gates, switching, and data storage. The second component is optical fibers and waveguides. Laser diodes generate coherent light used in photonic circuits. Then comes electro-optical modulators, which translate electrical signals into optical ones for processing. Then comes nonlinear optical devices. These enable complex computations by manipulating light in ways not possible with traditional linear systems. Now let us talk about photonic integration, where it is used. Silicon photonics stands as a key enabling technology driving the development of integrated photonic devices. These devices are rapidly increasing in complexity from thousands to millions of components, fueling advancements across diverse applications. Data centers, artificial intelligence, quantum computing. Despite its vast potential, photonic computing faces several challenges that need to be addressed to facilitate widespread adoption. These challenges range from integration complexities to manufacturing scalability. The first one is integration complexity. Integrating photonics with existing electronic technologies is challenging. Second is manufacturing scalability. Scaling a production while maintaining precision is difficult in current time with current technologies. The third one is signal loss, which is a major problem with the current technologies available in the market. Let us talk about future outlooks of photonic computing. The future of photonic computing is bright, with significant market growth and increasing investment from tech giants like Google, Microsoft, IBM projected in the coming years. If I talk about market growth, it is 2.4 times projected growth by 2034. Investments are also increasing by the tech giants. Technological advances. These advancements in photonic computing can extend Moore's law's limitations. Let us talk about Moore's law. Moore's law states that the number of transistors in a dense integrated circuit doubles approximately every 2 years, leading to exponential growth in computing power. As we can see in the picture, it's an exponential growth. As we can see in the picture. Photonic computing revolution. Photonic computing is set to revolutionize the world of computation by transforming computational capabilities and bridging physics, electronics, and computing. So, it's all about photonic computing. Thank you.